Kia ora, I'm Alister Christie, and this presentation is called Essential Pascal. I've been programming in Delphi for about 10 years now, mostly desktop type applications, with my main focus being on software for the real estate industry here in New Zealand. In my spare time, I practice martial arts, play guitar, invest in property, and I'm currently learning to play piano. I live in Porirua, New Zealand, with my partner Jackie. Marco Cantu has an ebook called Essential Pascal, and he has kindly given me permission to do some videos based on it. You can get a copy of his book from his website. The PDF version costs about $10, and I would certainly encourage you to get it if you haven't already, particularly if you're a beginner to Delphi. This video covers chapters 2 and 3, more or less, and I will probably do further chapters which will appear on my website, provided Marco is happy with this video. This session is targeted at beginners to the Delphi language and covers some basic aspects of Pascal. When learning any new language, the first application you're likely to write is Hello World. So let's do that now. So let's expand Delphi projects and create a console application. Now Delphi's created us the basic structure of the application, but I'm just going to eliminate everything that's not immediately useful. And write 2 lines of code. Write line hello world and read line. And if we run that, it does indeed print hello world. Now the basic structure of this program is we've got a keyword program and the text project 4. So we're creating an executable project4.exe. The next thing is this app type console, and this is a compiler directive telling Delphi to create a console application. Now the first bit of code is here, and so the code between this begin and end dot is what is executed when the program runs, and anything after the end is completely ignored. So I can actually run that and it doesn't affect it. In fact, there's a warning. Text after the end is ignored. So anyway, so right line, our first line of code, this right line, prints out the text hello world to the console, and readlin just waits for a carriage return. So if I remove that and run the application, it kind of flashes up briefly. So that's basically the minimalist hello world. Now if I copy that to the clipboard and I just hold down Control Z until we undo everything and paste my code back in. So I'll just go Control Shift I to indent that. And so now we've got some other bits. The first of which is this sysutils unit. So this user statement here says indicates all the other bits of or other units we want to access. And if I control click on sysutils, we'll see that there's some code in here. And in fact, if I go to the very end, there's 22,000 lines of code, so quite a significant amount. Now, the reason we need to use sysutils is because of this exception. Now, if I control click on exception, we'll see that this is where it's defined. We don't really care about that at this stage. And basically, if there's an error in here, it prints out what happened. And that's what this try except end does. So that's basically the program. This line here creates an entry in the to-do list. So if we go view to-do list, we'll see that insert code here, and if I tick that off, it converts from to do to being done. But I'll just get rid of that altogether. And I'll just run that once more to confirm to you that it does indeed still run. And the last thing we probably want to do is save our project. So rather than in projects, I'll check it. And we'll create a folder. Called console hello world. And we'll save the project. Rather than this project 4, we'll save it as console hello world as well. And that's our first application written. Now, sometime later, you're going to want to reload your project back. So you can either go File, Open Project, and go Browse to it, or we can go grab from the recent projects from there, or reopen from here. But anyway, we have our console application back. Now, because this application is so complicated, we will want to add some annotations to it to explain how it works. And this is done through comments. The first style is this double slash and anything after it. So if I type in a comment, anything after the double slash gets ignored by the compiler, which is quite handy if you want to comment out a line of code. You can just do that, and it no longer gets compiled. So our read line no longer works, so our application just falls through. Now, another style of comment is using these curly braces. And it allows you to do blocks of comments. And you can put anything in here except for another curly brace, which will close the comment. The last commenting style is this bracket star style, and it works just the same. And sometimes you want to comment out blocks of code that have comments in them, and the easiest way to do that is to use a different commenting style. So if you use this one normally, you can use this to comment out blocks of code that have comments, and they won't get confused. For instance, if I already have, in fact, let's change that style to that, and I want to comment out the entire contents of this code. I can't very effectively because there's already a curly bracket there, but I could do it with do it that way. Anyway, that's the three kinds of comments. Now, you'll notice that this looks like a comment, but it's not. As I mentioned earlier, it's a compiler directive, and this $sign indicates it's the case. And the last thing I'll mention in this little bit is that your colors are different from mine, probably. If you go into Tools, Options, and Editor Options, then Color, and go to Delphi, you can change your color settings to whatever you want. And so I have something different for comments and, well, compiler directives and comments. There we go, there's a compiler directive. And you can adjust them as you see fit. Just two last things on comments. There's a shortcut for placing a double slash. I can either type 2 slashes, or I can hold down Control and press slash, and it comments it for me. And if I do it again, it uncomments it. So you can quite easily comment out blocks of code that way. And the other thing I want to mention is, we already talked about the to-do list. And we can add a to-do item. If I press Control-Shift-T, we can say something like write German version. puts a little to do comment in there, and we get it in our to-do list. And if we save our project, save all. Now Pascal, and hence Delphi, in the code, upper and lowercase doesn't matter, they're both the same. So I can write this and it still works exactly the same. All in uppercase, all in lowercase, or some mix thereof, and it still runs and does exactly the same. Now, in addition to that, white space doesn't matter. Now, white space are things like spaces and tabs and what have you. So I can say something like this, and it compiles the same, or I can even put these on separate lines, and we still get our hello world as before. So it gives you a lot of flexibility on how you want your code laid out. But it does unfortunately allow you to do really bad things, like put all your code on one line, and that still will compile, but is becoming unreadable. Now, hopefully we get to talk about sort of how you should format your code a bit later, but let's just go back and lay this out how it was before. Okay, I'm just going to save that and to a new console application. And get rid of that and start with putting a readline in there. And let's go rightline hello for now. And we already know what this does, but we'll notice this stuff within the single quote marks is a string, and in fact we call it a string literal because it's literally hello. Now we can output other things to the console as well. Single character, which is actually treated differently from a string. Rightline number 5, 5.0, and so on. And if we run that, eventually we'll see that we get hello J 5 and 5.0, which in scientific notation, or more accurately, is 5.00000. Now we can also do other things as well. Now let's go back to our single right line and get rid of that. Now we can be a bit more sophisticated and say 5 plus 5 and run that, and we get 10. And we can go further and say 5 plus 5 times 5, and we get 30, because we get 5 plus 5 is 25, plus 5 is 30. If we wanted 5 plus 5 and then multiply by 5, we have to add some brackets. So there's a different order in which things are calculated, and different operators have different precedence. There are lots of other operators. We can do division, divide by 3, which gives us 3 1/3, approximately. And there's also this mod operator, which is, oh, actually, I should say, explain div first. This will give us just 3, because 5 plus 5 divided by 3 is 3 and a bit, and this div operator ignores the bit, so it's integer division. And if we do mod, it tells us what that bit was, which is 1 in this case. So yeah, so that's basically the integer, well, some useful operators, but I won't go into them in too much detail because we'll be going forever. But there's also logical operators. So I can say 3 is greater than 2. It's true. Not 3 is greater than 2 is false. Two plus 5, and just to make it clear, let's put the brackets around it, is true. So 2 and 5 is 7, which is greater than 3. And yeah, so pretty simple. Now that mostly concludes chapter 2. There are a lot of things I've just glossed over, but we'll be covering them hopefully in a bit more detail in later sections. So we're starting with our basic hello world, and we're going to extend it so that it asks for a name and then prints hello in that name. Now, to do that, we're going to need somewhere to hold the name of the person. So we need to declare a variable and call it name, and it's of type string. So I'm going to write ask the question, what is your name? And then we're going to read the response into the variable name, and then I'm just going to, rather than saying hello world, I'm going to say hello name. I'm just concatenating together these two strings with a plus operator. And if we run that, my name is Alister, and so it goes hello Alister. We can declare another variable. This time we'll make it a boolean, and we can say is assigned, so isAuthor is assigned name equals Alister, and we can say right and if we now run that, Alister and isAuthor is true, and run it again. Oh, I think I shouldn't do my name, I should do not Alister. So that's basically using variables. There are other types of variables, such as integer, if I can spell it correctly. So integer and char. Now, the thing about Delphi or Pascal is that it's strongly typed. So what I can't do, for instance, I can't assign a integer a boolean. So if I try running that, I get a compiler error, and integer and boolean are incompatible. There are, in some instances, you can assign things of different type, but certainly not these, and certainly I can't assign the string 42, but I can assign the number 42. Now, constants are declared in a similar way to variables. So if I declare a constant program author and assigned Alister to it, I can, if I change this to and run it, we'll get the same thing, but we'll just tidy it up a little bit. And it works exactly the same. We can, of course, declare additional constants, just like the similar way to variables. So declare a variable pi, declare a variable approx pi, which and so on. Etc. So this is a character, this is an integer, this becomes a either a single or a double, I'm not actually sure, but if we wanted to make sure it was a double, we could declare it as such. And let's make sure we haven't got anything wrong. And lastly, I should probably just point out that you can't change constants. And if we try to compile that, we get the left side cannot be assigned to. And you will have noticed we've got some of these things here. Our two variables a and b are not used, and neither is value. So these are just hints. The very simplest ordinal type, or one of the simplest, is char, which is just a single character. And I've written here a program to read a character in from the console, which prints it out and prints out its ordinal value, which is basically just its ordering. So it's a number based on its value. And if I run that into H has the value 104, and run it again, I has the value 105, which is the next character, and capital I has value 73. So capital I comes before little I in terms of ordering of characters. Now let's uncomment this a little bit here. Now for ordinal types, there is a function called pred, which gives you the previous value, and successor. So let's run that and into H. So the value of 104, previous was G, and the next is I. I have here a small application, which is actually the largest one we've written so far, that displays various aspects of some ordinal types, in particular anti-char, char, small int, integer, and int64. And it tells you how much memory each takes up. The size of function tells us that, and the low gives us the smallest value, and ord gives us the sort of integer representation of it. So we get the smallest number that can contain and the largest number that it can contain. And if we run that, I've got these tab characters in here, which is declared a constant up here, just so they all line up nicely. And if I run that, I get anti-char is 1 byte. It can contain from 0 to 255. Now I'm compiling this under Delphi 2009, so a char is 2 bytes. If I compile it under Delphi 2007, anti-char and char would be the same. So char is a wide char basically, so Unicode. So 0 to 65,000. Small int is also 2 bytes, plus or minus, and so on. So integers plus or minus 2 billion, and int64 is 64-bit integer. Takes up 8 bytes of memory, and plus or minus really big number. There are 3 real types: single, double, and extended. A real type is a floating point number, which something like that is a floating point number. A single is 4 bytes, a double is 8 bytes, and extended is represented by 10 bytes. And we can prove that. Size of extended, and run that, and we get 10. Now, I was going to write a clever application to demonstrate the differences and what you can do with floating point numbers, but I couldn't think of anything interesting. So instead we're going to look at the math unit. And this contains high performance arithmetic, trigonomic, and so on. Lots of mathematical functions. And so if we look at some of these constants defined, the minimum single number we can represent is 1.5 times 10 to the minus 45, and goes all the way up to 3.4 times 10 to the 38. And of course, a double can represent more, and an extended even more. And further down, there's some constants. So not a number, infinity, and negative infinity, which are special representations of floating point numbers, because you can actually represent infinity in bytes. There's a special number for it. And lots of functions. So, and lots and lots and lots. So if we go in here and set log to the base 10 of some number, and ran that, we get a result. And you can probably play around with these for however long you want, basically. In Delphi, dates and times are represented by tDateTime, and tDateTime is in the system unit, and it's declared in the system unit, and it's just a floating point number. It's a double. Now, dates and times are represented as number of days since a particular date, and we'll get to that shortly. And so basically this program is just grabbing the current date, now returns the current date and time, and we're printing it out. So let's run that, and we get a number which is a little bit over 40,000, which is not very useful. So it's about 40,000 days since this particular date. Now, if we call this function datetime to string, or to str, and control click on it, it calls datetime to string, and it just converts the date and time to a string, rather obviously. And we run it, and we get the current date and time. Now, if I change this to 0, this is the, well, day 0, which is 30th of the 12th, 1899. So anything smaller than 0 is before this date, anything bigger than 0 is after this date. And if we wanted midday on that particular date, we could go 0.5. It's half a day. And we do get, in fact, midday. There are, of course, lots of other routines associated with dates and times. for instance, encode date. So check in my birthday, and that works. We could say day of week, and it's the first day of the week, and it doesn't actually tell us what day that is, and we can use long day names, and we haven't actually covered arrays yet, but I'll just skip ahead slightly, and there we go, it's a Sunday. But anyway, that's a very brief introduction to tDateTime. One way of converting between types is using an explicit typecast. So I'm saying convert x to an integer, or and put that in n, and convert it back to a character, and what does 0 represent as a boolean. And if I run this, it works, and we get 120x and false. Now I could try and convert the string hello world to an integer and run that, but we can't. It's an invalid typecast. Likewise, if I went 3.14, that's also an invalid typecast. So typecasting allows you to convert between some types. The number is actually quite small. The better way to do it is using a function or routine to convert a value from one type into another. For instance, we can call trunc, which will chop off all the extra bits, and we'll just get left with 3, and character 3, which is in this case represented by a heart. And there are heaps of others. We looked at datetime to string and a few others. We can go string to int, except it's strat int, 1023, and we have some problems. Except I need to make it a string. And there we go. And character 1023 is not actually a question mark, it's a character that can't be displayed on the console. Thanks for watching my presentation. I've gone a little bit over time, but I was trying to cram about 2 hours of concepts into half an hour, which has made my coverage of the topics a little bit rough. All the better for the sales of Marco's books, I guess. Marco has written many other Delphi books, the Mastering Delphi series, the latest one being for Delphi 2005, and his Delphi 2007 and 2009 handbooks, all of which I have and would recommend. If you would like to see other videos by me, go to codegearguru.com.